Hello, everybody. Today, we're going to talk about our final lesson of Algebra 2, dealing with regression. All right, in this lesson, we're going to discuss parts of our projects and new expectations. We're going to give some regression modeling. We're going to, do a quiz in class and work on project. Announcements. Now, before I continue, I will say this lesson is it's a lot. It's not it's not gonna be a short one. It's going to be lengthy. There's gonna be a lot of talking and a lot of typing for us to do. All right, now time for some hard talk. So I need for my juniors to grow up and don't act like you're 7 years old. One of the issues that I have seen as of late is like anytime when I try to teach a lesson, it's a problem. Basically, you guys crying and nagging. Did we not have pretty much close to 2 weeks, so pretty much just a week of chillaxing after you guys took the ACT before we was out of school? So I don't quite understand. And then before we took the ACT, things was light. So I don't understand the issue of, oh my God, we gotta learn. You have to learn. When you have an attitude of that, you're not showing me that you are a student, and your grades are going to reflect just that. I need for you guys to grow up. You're gonna keep having lessons. You're gonna keep being taught, things. Even after I get through teaching this last lesson, there's still things that you're going to have to be taught, and that's even including reteaching, because you guys don't tend to remember things that you done yesterday. So, and I'm gonna say this to you guys one more time: you are responsible for your work no matter what. And that includes absence, because one of my issues I'm having with you guys that's going to be a bit problematic for you is that you miss days and you think that you're excused from it. It doesn't matter if you're doing stuff for the superintendent, you're still responsible for the work. The only difference is that I have to make sure I give it to you. And of course, it's always and forevermore being Google Classroom. You have to do it. When you miss, it does not mean that I have to sit and teach you the lesson that you missed from start to finish. I'm not doing that. If that's an issue, by all means, we could have a conference. I got no problem with speaking to your parents. I got no problem speaking to your parents in front of the principal or superintendent. Because again, the expectation has been said to you over and over and over again. So you are responsible, not I. When you miss, does not mean that I will be teaching you what you missed. That's the reason why I create these videos, so in case you do miss, you can watch and get caught up on it. Or, as I always tell you, you have permission to come into any of my other class periods to catch up on any lesson you missed from the next day, provided you have a pass from your teacher. All assignments that I'm posting for my absent students, you still have a deadline to do them. You choose not to do them, we're not playing a makeup game because you juniors are becoming seniors. And with what's going down senior year, you guys won't have these, extended time, extra extended time to get work done. All right, junior project must be completed by all students despite your status. And let me remind you, those who score 23, the only difference is you won't have to do the test component of this project. That's the only difference. Tests and quiz, you don't have to do them, but everybody is subject to the EBR stuff and this project, with the exception of those who got 23 and they could only skip the quizzes and tests. All right, and again, this project is multiple assignments. And yes, it is worth lots of points. Again, it ranges from 1,000 to 3,000. Of course, I'm not going to hit the 3,000 point line, but it's going to range in that scope of sequence. All right, And again, when you are absent, it's gonna be hard for you to get things. So that's why when you're absent, watch your Google Classroom, do the stuff, and get it done. The Kahoots that I have posted, y'all, please get them done, because once they close, it's over. All right, this week and next week, again, we got a lot going on. We're gonna finish our last lesson of the year. We're gonna work on our reflection activities. We're going to statistics. I am going to have a note check of all statistics lessons. That's going to be worth 100 points. So I'm looking for everything, even the basic central tendency, mean, median, mode. Now, if you was absent, again, watch the videos of central tendency. And the notes could come from, again, the videos that I post in Google Classroom and the stuff we've done in class. You're going to take lots of quizzes and EB or benchmark, and a lot of solo work will happen. So, the groups, I had to break up for quite some time. Now, the activities, that's the only time you're going to be in groups, but for reflection, all of that, that's every man for themselves. Reminders, you have to complete project part 1, design an experiment, and data analysis on bank ATMs by the end of this week. So everybody, with the exception of third period, has that assignment. If you was absent, see me quick. After that, that's it. Now, you was absent, you lost a copy. I cannot make you another copy. What I can do, I could scan it and post in Google Classroom for you to do. But one thing I'm not doing, because again, that printer that you see in the classroom belongs to me. That ink belongs to me. So I'm not duplicating anything. Binders. Let me look at that. Binders must be organized and put together by next week prior to spring break. This is worth 150 points. No further extensions been given because I've been telling you about getting our binders together, since we came back. So you look at the points in the red because there was some that were worth 100 points, just your notes, and then another 100 points for the ATM machine and the data analysis, and then putting your binder together, putting it together, organized in a way of the junior project. That's 150 points. Have it done. Because you don't have it done by the time we go for spring break. In fact, I'm putting grades as we doing them in. All right. The precise definition of mathematics. This is critical because throughout projects, quizzes, and tests, and anything of that, I have to see that. I must see it. It's the techniques to explain, understand, and manage reality by ciphering, counting, measuring, classifying, ordering, inferring, and modeling patterns arising in the environment. That is the precise definition of mathematics. And you have to be able to know that and have to be able to explain that in every asset. So again, this is in every part of the portfolio. How did we satisfy the precise definition of mathematics? That's going to be a question that you're going to have to answer in different ways. You will not, the same answer will not work. So make sure you know this definition and you know how to put all those pieces together. All right, academic integrity. Again, just for a reminder, we're going to do projects and stuff like that. Cheating, that's not how that's going to work. It won't be allowed. All right. Phones. One of the things that's getting y'all in trouble now this fourth time week, because I guess you guys got a little lazy, is phone situation. I don't want to see you on your phone. Don't even sneak on your phone. Otherwise, I'm going to sneak on grades. Don't do it. I don't want to see it. For any reason, don't have it out. Put your phones up. Now, when we get to May and all of that, then it's cool. But for the rest of this month and throughout April, it's a lot. All right. There go some more points being thrown at you. Statistical reflections worth 300 points. You're going to write and type in your own words what was taught and learned. This will be typed up in pair, of course. However, you must also write up what you have learned regarding statistics. All right. But what I'm probably gonna end up doing is making you put it in Google Sheet. So I'm gonna say Google Sheet right here. Well, not Google Sheet, Google Doc. I'm sorry, y'all. I'm gonna want Google Doc of that because I have to be able to see, what you learn out of that. Again, you have to use examples from class, what was taught, what did you do personally, and stuff in Google Classroom videos related. So you are responsible for that. I will have a rubric posted on this so you can understand what is expected of you. The reflection is solo assignment. No teamwork is allowed. I have to have it in your teenage words. Your words. I don't care how childish they sound, but they have to be done in your words. Now, there's going to be a little bit of some grammar rules being involved. But you're going to have a rubric posted. And you could ask me questions about that, and I would answer them completely. So, there you are. And that's going to be due also right before spring break. So, there you are. A lot of points thrown around, huh? Consequences of the academic dishonesty. You getting tested on the spot and or zero. You won't get one on both. So just don't do it. Don't AI answers. Don't get someone else's answers because I'm reading these docs carefully. All right. So let's go ahead and get into these last lesson. So the lesson starts out with correlation. And when we think of correlation, you want to think of a relationship. A correlation is a relationship between two variables. Correlated variables change together. Correlations are sometimes called trends. All right. Remember, in the beginning, like right in the middle of the school year, we did like graphs and stuff. So when you think of correlations, you're thinking about, a bunch of scatter plots all over the place trying to form a singular shape. All right, important notes. You can use a correlation relationship. I'm sorry, I'm tripping. You can use a correlation coefficient represented by the variable r to tell how strong correlation between two variables is. Correlation coefficients are numbers that range from -1 to 1. If two variables have a correlation coefficient of 1, then it's perfect positive correlation like me. If two variables have a correlation coefficient of -1, then it's perfect negative relationship. Still, because I am perfect, I'm also negative. If two variables have correlation coefficient of 0, then there's no correlation. That means there's no relationship. That means it's whack. All right. So you see a bunch of dots forming linear shapes, right? But and that's okay. So when they form a singular linear shape, it's a perfect relationship. And we measure this by the r value, lowercase r value. So when it's r equals 1, it's perfect. When it's like 0.95 and to 0.7, and that's positive, that is, it's a strong relationship. But anything below a 0.66, a zero point 0.7 relationship, like 0.66, it's a weak relationship because it doesn't really form a shape. It's more scattered. So when it's -1, that means that it's decreasing. but it's perfect and negative like me. Again, it's like 0.97, and again, between, 0.99 to 2.7, sorry, it's going to have a strong relationship, but it's not perfect because it's not positive one or negative one. But you see how this is negative 0.49? This is weak. It forms no shape. But when it's all over the place, when it forms no shape at all, it's r equals 0. All right? So that's just telling you about, the relationships. Now that's the mathematical sense. All right. Now let's go over it before we get into the application sense. So again, based on how it forms a line or a linear shape, you're going to notice we try and get that perfect positive correlation. Now, if it's strong and positive, it's going to get close to forming a line. But again, if it's 0.67 and below, it's not going to really form a shape or a line shape in particular. So that's what you just got to keep in mind. So, perfect, strong, and weak positive. And you have weak negative, strong negative, and perfect negative, which is just like me. All right. So here's an application situation. So one of the things that you're going to have to do, you have to be able to explain graphs, scatter plots, you know. So here's the situation. We are at some water park and we try to monitor, the park attendance. So, you own the business like a water park, you're looking at, how many tickets are sold. But these people, not looking at only just at the tickets being sold, but also the high temperature. So they're trying to see if there's a correlation or a relationship between hot temperatures and the numbers of tickets being sold. Now we look at this graph, it has a strong relationship because it looks like it almost forming perfect. If it is forming a line, it's good, but it's not like perfect, but it's good because most of these are pretty much close to a line. So because of that, we can say the scatter plot shows a positive correlation because the daily high temperature increase, the number of measured tickets sold also increased. The correlation is strong because the data points fall close to a straight line. So that's what you're going to end up having to do as you go through your reflections, and you too going to be looking at some data at some point to determine such things like that. All right. So this is an example, which, for the video's sake, we're not going to do because this is something that's going to be done in class. So this is a real life situation, and all we're going to do is go to Desmos and deal with and find the correlation. So we're looking for that R value to determine the relationship. And Desmos do that for us, but we're not going to do it in this video. All right, a correlation, just remember, it forms the shape of a function. Not only as linear, but also forms a quadratic shape, polynomial, exponential, everything that we talked about throughout the school year, including trig functions, which is called sinusoidal functions. I would take my time to explain that word to you. And these are the shapes of the functions that we'll be dealing with. These are the scatter plots that they form multiple shapes. This is the sinusoidal function. This is a square root function. This is an absolute value function. This is a exponential, cubic. This is a logarithmic or a logistic. I could be wrong on that. So let's just call it another square root. No, I'm pretty sure I'm right about this. Logistics are rarely used. This is quadratic and this is rational. So again, all the functions that we've been talking about throughout the school year. And you're going to realize in statistics, we no longer call them functions, we call them something else. All right, so let's look at correlations and causation. Just because two variables are correlated doesn't necessarily mean that the one variable causes the other. It could be a random coincidence that the variables are correlated. You're going to do more research to find out. And you're going to see in a moment, and some of these example that I will bring up is going to be a bit personal. Because I want you guys to get a good sense of understanding about correlation and causation. So just be careful. Other quantities may play a factor of these, so let's talk about them. Example, here's one that we all can relate to. Students who use their phones more at night sleep less. Now, this is a issue because phones don't, it's not the reason why people don't sleep good. The reality is students staying up late is very reasons. And sometimes they just happen to be on their phone. I mean, you could think of stress, You could think of lack of structure around the house or something was going on, And the phone, just calm them down a little bit. So that's an example that shows that, correlation does not imply causation, cause and effect, you know. Here's one that's even more personal to us. Neighborhood academic performance. So here's an observation, and this is something that, even I take offense to. Test scores are always low in 70805. So this is what they're trying to say to us, that living in the area makes you less intelligent. So again, correlation does not imply, causation. So that's not a cause and effect. Just because you got low test scores does not mean that you are, less intelligent. Intelligence is not determined by zip codes. That's the reality. But again, that's the, correlations that we're currently dealing with at our school. Because of the neighborhood, people think, the test scores are low. Or the test score are low in the zip code, but that's something that's not necessarily true. There's other reasons why this can happen. Maybe because there's no access to tutoring, the curriculum may not provide good quality for the students, or there may not be any money to help us to become better. So, you know. So, long story short, when you think of correlations, you just cannot, make assumptions like this. You know, just because a person come to school, musty doesn't mean that they poor. That's one thing we just gotta be careful about. But that's how statistics operate, cause and effect. But we gotta be careful and make sure we don't make the wrong cause and effect. All right. So that's a video. I don't know if we can watch it here. I don't think he's not gonna let me watch the video while playing the video about ice cream sales and homicides. So here's another good example. So the the more ice cream that's being sold, the more homicides, which we know, that don't make sense. But the video is really good. It will give you the more details about causation and correlations and causation. Again, correlation does not imply causation. All right, let's move on. Or I guess not. Uh, all right, we're gonna skip that. So, for this video, I would just link it. All right, I'm gonna link it into the video when it's posted or put in Google Classroom. So now let's talk about regression, making prediction. So, what is regression? Regression is a method we use to model the relationship between two variables and make predictions, sometimes more than two. All right, so think of it this way. You have a bunch of data points, and regression help us draw the best line fit that summarizes the trend. Now, like stated earlier, going back to the correlation, a strong correlation just forms a shape. Now, it doesn't necessarily mean it's just a linear shape. It could be any other shape that resembles a function. All right, so yeah, look, these are all the functions that Desmos would do for regression. Now, the raw function no longer exists. We call these functions models. These are models because these deal with real life patterns and real life situations. And again, we build these models based on the patterns we see, i.e., Desmos. So, one thing I want you guys to understand, Desmos mainly do regression for polynomials such as linear, quadratic, cubic, quadratic. All right, and power. And then you're going to have, well, power is not, well, yeah, you call it a polynomial if you want to. Exponential and logarithmic are non-polynomial functions. All right, so is logistic and also sinusoidal functions. Or you just call it a sine function if you don't want to take the time dealing with that pronunciation. So just be careful with that one. So that's what it deals with polynomial versus non-polynomial. And yes, it does not do rational functions. Rational models, are mainly used in terms of, they're rarely used in real life. I'm just going to keep it 100 with you. So let's keep it pushing. But these are the models that you're going to have to know how to use. All right, just note the regression gives you the model. Correlation tells you how well the model fits the data. So the correlation value R, lowercase r, that you saw earlier is for the linear relationships, but R squared is for all the other functions that we covered throughout the school year. R or R squared tells us how well the regression tells us how well any regression model fits the data. A high R squared points too close to making a perfect model and good predictions could come from it. But if it's low, it's going to be bad for predictions. Just remember, R squared is always between 0 and 1 and never negative. but also be careful when it equals 1. And you want to see a little bit more of that y at the end of this. All right, so you guys, this is an exponential model. And of course, I will link, oh, I'm sorry, how to put these regression models in decimals. All right, we're going to do it in class. And if you are absent, please watch the video about doing the regressions in decimals. All right. So here's something about exponential model. So a few years ago, Matt planted some English ivy on a hillside in his backyard. The ivy has grown aggressively since then. This table showed the area of Matt's yard in square feet that was covered with ivy each year since Matt first planted it. So x being the independent variable dealing with years, which we know is always time when we're dealing with trends, and area is the dependent variable. So once you learn how to type this bad boy in, type this in, you're going to get A and B. You're going to substitute A and B into this model right here. Now, and you're looking at the correlation, like we talked about, correlation tells us, how strong the relationship is and how good of our model is for predictions. We are almost close to 1. So this is a strong model used for predictions of exponential models. So that means we got a good model. And again, anything less than 0.70, 0.7, you don't want to use that model to make predictions because it's weak. Now also, Desmos shows you, Desmos will also do the model for you. So I want you to get in the hand of typing it because when you're doing it in pair, you're gonna have to type. You cannot just go to Desmos and do all this, all that. It won't work. All right. So when you want to, get the practice for it to just feel for the correlation value or just to check your work, when you go to your table, click here. When you click here, it's going to give you this guy right here, and you're going to click on exponential regression, and it's going to give you everything you need. It's going to give you that R square value. Again, R square is used for all other functions but linear. And it's going to, instead of giving you A and B, it's going to create the model for you. So you don't have to create it yourself. But unfortunately, for quizzes and test purposes, you're going to do that yourself. All right, final note. What does it mean when you have a perfect R square? Meaning that that correlation is spot on perfect. So it means that the model just fits perfectly. That means every data point lies exactly on the model. There's no error, no type of error. The model explains 100% of the variation, but this can also pose a problem. So sometimes it could overfit. So it will memorize the data, not the pattern. So be careful with that. And sometimes it could leave you with a fake prediction. And we know for a fact life is not perfect. So if you think you're perfect where it's not, something wrong. Unless you're Mr. Howard, which you are perfect. So no one's Mr. Howard. So don't even try it because you can't be Mr. Howard who's perfect. All right. R squared equals 1 means that it's perfect fit, but it does not always mean that it's the best model. So always review it unless you are Mr. Howard. All right, so here's a question to further connect what I was telling you about R squared being 1. So if I use a quadrant model, and a quadrant being, looking back at your handout, it being x to the power of 4. So remember, it goes 4, 3, 2, 1 constant on that 5 data points. And I get r squared equals 1. Is this the best model? No, because it's likely overfitting. And remember, a quartet model, it gives you 5 pieces. So if you got 5 pieces on 5 data points, of course, it's going to give you 1. This is like giving a quadratic, which is 2 for the exponent. You're getting there um, 2 data points. So that's why it's not going to work, because again, you got 5, pieces for the model with 5 data points. So of course you can get r squared to be 1 always. Again, with linear, if you say 1, data point, and you say linear, of course, r, lowercase r equals 1. If it's quadratic being 2, r squared is going to be 1. It's the same thing. If it's cubic 3, you know, and you do it for 4, same thing. So, bam. Well, actually, let me correct myself. Linear is going to be 2 because it's going to be x and your constant. So you have a linear being, x on your constant, if you got 2 data points, guess what? R is going to be 1. If it's quadratic being x squared, meaning that it's going to be 3, x squared, x, and constant, and you got 3 data points, r equals 1. So that's r squared equals 1, so that's why you don't do that. All right, again, has 5 parameters for the quadrant model. And then you get 5 data points, so that means the model just have enough control to pass to every single point exactly with no problem. So we're going to stop right here because this problem right here is for you to do in class. And again, I will be posting other videos to supplement this one because this is mainly to be done in class. All right.